Let's look at an example of finding real zeros of a polynomial function. Let's consider function f of x equal x cubed plus 8x squared plus 11x minus 20. To find the zeros, we could try to factor this polynomial and see whether they are factors of the form x minus c. Each factor x minus c would produce a zero c. However, none of the techniques that we learn in factoring section can be used here, since there is nothing to factor out, and grouping does not yield common factor. So we have to look for another way of finding the zeros. Since we are interested in real zeros, we can start by checking whether there are any rational zeros. And for this, we can use rational zeros theorem. Rational zeros theorem is applicable here since the polynomial has integer coefficient. So if there are any rational zeros, they are of the form p over q, where p is the factor of the term a sub 0, which in this case is negative 20, and q is a factor of the leading coefficient, so it is a factor of 1. Factors of negative 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. However, factors of 1 are just plus or minus 1. Therefore, all possible rational zeros are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Let's check whether any of these numbers are actual zeros. So let's check the simplest one, x equal 1, and let's check whether x equal 1 are a 0. How do I check that x equal 1 is a 0? Well, I will use definition. We'll compute the value of function at 1. And the value of function at 1 is 1 plus 8 plus 11 minus 20, and that's clearly 0. So the answer to our question is yes, this is a 0. So if this is the case, we can write the function f of x as x minus 1, since x equal 1 is 0, x minus 1 is a factor, times q of x, where q of x is the quotient when dividing f of x by x minus 1. So we'll find the q of x here, and we'll find q of x using synthetic division. So the coefficients of f are 1, 8, 11, negative 20. We are dividing by 1. So we'll write the setup and now perform synthetic division. We'll write of 1. 1 times 1 is 1. 8 plus 1 is 9. 1 times 9 is 9. 11 plus 9 is 20. And 1 times 20 is 20. And negative 20 plus 20 is 0. 0 is the remainder. Everything else in that row form the coefficients of q of x. And therefore, q of x is x squared plus 9x plus 20. This polynomial can be easily factored. This is quadratic polynomial, and it factors as x plus 4 times x plus 5. Therefore, taking q of x to my formula for f of x, we can obtain f of x as the product of x minus 1, x plus 4, and x plus 5. Since f of x is the product of the factors x minus c, each such factor produces a 0. So the zeros are x minus 1 produces 0, 1. X plus 4 gives the 0, negative 4. And x plus 5 gives a 0, negative 5. So these are the zeros of my polynomial. The step above is the function f of x in the factored form. This was another objective in this problem.